And so now we're going to move on to our next functional group, which are the alcohols. And alcohols, their functional group is the hydroxyl group. And the hydroxyl group is just an oxygen bonded to a hydrogen. Okay, the structural formula is R. So this is a chain of carbons, one or more carbon. And then to one of those carbons, you will have this oxygen bonding to the carbon and then a hydrogen bonding to the oxygen. Okay. You also need to be able to recognize a chemical formula. So if we're identifying alcohols, you have to be able to look at it structurally, so looking at a structural equation or the chemical formula. And so when you see alcohols written, it'll be a chain of carbons with some hydrogens and then an OH attached to it. And this is actually methanol. And then another one could be C2H5OH, and that would be ethanol. Okay, so what are they used in? So they're used as disinfectants, which you guys are all familiar with right now in our current environment. So you'd see it in hand sanitizers. We also put it as a fuel additive. So if you buy your gas, I believe Husky gas stations will put ethanol in their fuel, as well as we use it as a solvent, so to dissolve things. Another one, alcoholic beverages. And we also use it in the production of drugs or pharmaceuticals. Okay, so that's our second functional group. And so again, if you go back to your data booklet on page 9, you will see here's our alcohols here. Okay, you'll notice here's the functional group hydroxyl. Again, they give you an example. So we've got 2 carbons, so that's our ethanol, and then the hydroxyl is the ol sound, OL. So there's always examples in your data booklet that you can go back to if you forget how to do the naming. Okay, so let's turn back to naming alcohols. Okay, and let's write this down into your notes. So how do we name alcohols? Okay, so the first thing you have to do is you have to identify that there's a hydroxyl group on the chain of carbons. And in this case, we're gonna identify that there's a hydroxyl group. So that OH on an end carbon. Okay, so if we were to draw the diagram, okay, so when we see the hydroxyl group, the OH on an end carbon, the first thing we're going to do is we are going to name the parent chain. And this always goes back to the same way that we've been doing it since we did our hydrocarbon review. So we're going to use that table on our data booklet that gives us the prefixes for all of our carbons. Okay, and we're going to figure out the longest chain of carbons. So here's our longest chain of carbons. Okay, so look up 2. So we've got 2 carbons. 2 is equal to F. Okay, the bonds are single bonds. So that's going to be ane. So now this will become ethane. Okay, What we're going to do then is we're going to now, the second part of this is to now drop the E on the end of methane. And then we're going to add the ending all. Okay, so once you see this hydroxyl group here, that tells you drop the E, and we're going to add all instead. So now our name becomes eth and all. Okay, so eth tells us 2 carbons, the ane tells us single bonds, and the all tells us on an end carbon is hydroxyl or OH group. Okay, let's try another example here. So let's try this one here. Okay, so when we look at this one, how many carbons in our chain? There's 1. So 1 carbon, if you take a look on your data booklet, is meth. There are no bonds, so we're just going to say methane would be the ending. But we're going to drop that E because we have the hydroxyl group, and now this becomes methanol. Okay. Okay, so if we go beyond 3 carbons in our parent chain, it means that the hydroxyl group could be somewhere in the middle, okay, of the chain. So our second set of rules is, okay, if the hydroxyl group is on a middle carbon. Okay, so let's take an example. So let's do 3 carbons, all with single bonds between them. And then on the middle carbon, we're going to put the hydroxyl. So remember, the carbon's bonding to the oxygen, and then the hydrogen is bonding to the oxygen as well. Let's fill in our hydrogens. Okay. Okay, so what we have to do differently now is just like with all of our other functional groups is that we have to give locations. So it's the same as above. But now we have to add a location number. For the OH group. Okay, and we're going to do it very simple, very similar to when we did the double bonds. We put the location number in front of the all symbol. So just like if you think back to the double bonds, we said 2-ene. Now we're going to say 2 or 3 or whatever the location number is all. Okay, so let's do this example here. Okay, so again, we've got 3 carbons. So 3 is prop. Single bonds, propane. We are now going to number our carbons. So I'm going to start here and go left to right. 1, 2, and 3. So now on my second carbon, there is a hydroxyl group, all. Okay, so propan to all. And that would tell you that you now have a hydroxyl group on the second carbon. Okay, so let's go into your workbook and turn to B18, and at the top of that page you will see a couple examples. So we'll do the first 2, and then I'll give you some time to do them on your own, and then yeah, so let's do the first 2 together. Okay, so let's take a look at naming this alcohol. So again, there's our parent chain, 2 carbons. 2 is F. The bonds are single, so ane. We're going to drop the E because we see this OH group, and we're going to turn it into ethanol. Okay. For number 2 now, if we're drawing the alcohols, we work the same way. So we have to identify prop is 3 carbons, ane, single bonds, and then our all tells us there's an OH group. Okay, and because they haven't given us a location number on this one, and we've got more than 2 carbons, we're always going to put it on a terminal carbon, so at the end of the carbon chain. So only if they give you a location number will you actually follow that location. If there is no location number, then we'll put it on an end carbon. Okay, so let's draw this out. So prop, 3 carbons, 1, and all of them have single bonds between them. Then I'm going to choose one of my end carbons. So I'm going to put my hydroxyl group here. And then I'm going to draw in my hydrogens to make each carbon have 4 bonds. Okay. So remember, all carbons need 4 bonds. Hydrogen only needs 1. And just as a reminder up here, oxygen, or the O, needs 2. Okay, so if you take a look, this oxygen here is bonded to the carbon, this bond here, and then there is a bond between the oxygen and the hydrogen. So it's got 2 bonds in it. We just write the OH together as a group. Okay, so again, you can also do a condensed structural formula if you want to, and we would write it like this. So we'd keep the OH, the hydroxyl group, on its own, and then we could say on this carbon, there are 2 hydrogens, the second carbon, there is 2 hydrogens, and on the third carbon there are 3 hydrogens. Okay, so both of those will work when you're writing out answers on a quiz. Okay, so I'll give you some time now, finish up the rest of those examples, and then we'll come back and we will start talking about carboxylic acids. So if you want to pause the video, give those a try, and then when you're done, we'll come back and we'll talk about carboxylic acids. Okay, so back into your notes now. Carboxylic acids are our next functional group. So carboxylic acids are just organic acids. Okay, and we have our carboxyl group. And the carboxyl group is a carbon with 2 oxygens and a hydrogen. So that's how we write it out as a functional group. Structurally, it's got an interesting shape. So we can have, in this case now, a chain of carbons, or it could be a single hydrogen. And bonded to that chain of carbon or the single hydrogen, so it always has to be on the end, will be a carbon, which has a double bonded oxygen, so 2 bonds between this oxygen and carbon, and then an OH group attached to that carbon as well. So you'll notice now that we've got a double bond here between our oxygen and carbon, but the carbon still has 4 bonds. We've got 1 here, 2, 3, and 4. Okay, so this R bracket H can be a chain of carbons, so it could be 1 more carbon, it could be 3 more carbons, or it could just be a hydrogen. Okay, chemical formula now is going to be similar in the way it looks to an alcohol, but instead of having the OH tagged onto the end, you are now going to have a chain of carbons, so C, 1 carbon, H3, and then we'll see COOH on the end of the formula. Okay, so where do we find these? So these are found in citrus. So these are found in citrus fruit. We also use it in vinegar and vitamin C. Okay. We also use it in pickling. So that would be our vinegar. Okay. And they will have all the same properties. So So it has the same properties, whoops, as our other acids. So pH less than 7, they're conductive, they turn blue litmus red, all those other things. Okay, so now we need to talk about naming. Okay, oh, sorry, and we should go back again. Remember in your data booklet, now we're here on our carboxylic acids. Okay, so they give you this R. They don't put a hydrogen there, but it could be a hydrogen. Okay, and then if we look here, we've got 2 carbons. That's our eth. We notice the functional group here, which tells us oic acid. Okay, so let's go back and let's write out the rules of naming carboxylic acids. Oops, wrong page. Here we go. Okay, so how do we name? Naming organic acids. Okay, so same idea as our alcohols. We're going to name the parent chain. So whatever the parent chain is, we are then going to drop the E at the end, and we are going to add oic acid. So the oic goes on the end of the parent chain, and then acid is a separate word. Now, there's no location numbers on these because the carboxyl group has to be on a terminal carbon. It cannot occur in the middle of the chain of carbons. Okay, so there's no need for writing out the or giving a location number. Okay, so here we go. Let's try this first one. Okay, so again, parent chain first, 1 carbon. 1 carbon is meth. So normally we would have called this methane. Okay, but because we have this functional group here, okay, it tells us it's an acid. So we're going to drop that E, and so now our new name will become methane. We're going to put oic on the end, and then we're going to add acid. So it becomes methanoic acid. Okay. Let's try another one. So let's try this one here. So now the terminal group doesn't always have to be to the right. We could actually write it this way. Oops. Wrong color. So we could also write it this direction as well. Okay, so again, let's take a look at our parent chain. 2 would be ethane. Here's our functional group. So we turn it to oic and we say acid. So ethanoic acid, which is also the stuff we put on French fries. If you like it on your French fries, it would also be vinegar. Okay, let's try one more. And this one we'll write it as a condensed formula. So let's do this one. CH3 bonded to CH2 bonded to C carbon with the carboxyl group. Okay, so again, let's take a look at our parent chain. So we've got 3 carbons, so that would be prop, and here's the functional group. So now we say oic acid. Propanoic acid. Okay, here's another one that you create in your body when your muscles get tired. Anyone remember that from Bio 20? It looks like this. So this acid actually has a hydroxyl group on it. Anyone remember what we produce when our muscles get tired? Yeah, that would be lactic acid. Okay, and so this fatigues your muscles. So when you don't have enough oxygen, you go into anaerobic respiration and you produce lactic acid, which tells your muscle or your body to slow down because you're not getting enough oxygen to go through cellular respiration to make that energy that you need. Okay, so let's try a couple examples together. So in your work booklet, you're going to turn back to B18, and we'll try the first two on this diagram, or sorry, on the worksheet at the bottom here, and then I'll give you some time to do your own. And then we'll come back and we'll talk about esters in another video. Okay, so B18 at the bottom of the page, let's take a look at this first one. So again, this is a condensed structural formula. So here's our parent chain here. So let's count up how many carbons. 1, 2, 3, 4, 5. 5 is pent. It's all single bonds, so it'd be pentane. Now recognize here the carboxyl group. So now we put on the ending oic acid. Okay. Okay, so here we go. Here's another one. Now we're going to draw. So again, we have to just work our way backwards. So prop tells us 3 carbons. The oic acid tells us we're dealing with a COOH group. And so now we're just going to draw it out. So propanoic acid, 3 carbons. On an end carbon, doesn't matter which one, we have to draw the hydroxyl group. And fill in our carbons. Okay. And again, you could do it condensed. So it would be CH3, CH2, C, with the carboxyl group on that last carbon. Okay, so give these a try, and then when you're finished that, I'll have another video for you on esters.